Pressure is a scalar quantity, but it's useful to think about the direction that the force that we're describing with that pressure would act. If we have a situation here where we have some container with, say, a gas molecule inside, and that gas molecule is moving over this direction and it's going to strike the wall of the container at some angle here. As it does that, there's going to be some interaction between the molecule or the atom there and the wall, and this is a collision. So you might get the sense that the wall of this container is going to be experiencing a force. It'd be a little bit over to the right, maybe a little bit over here, and then also a little bit down in this direction, and you'd be right. It does feel both of those forces. So a little force here and a little force there, so with all these different molecules around, you might think, well, this becomes a really complicated case. What happens here though is that we have a large number of molecules that are all moving around in basically random directions. So for every molecule that hits at an angle like the first one did, we've probably got another one that's going to hit at the opposite angle. And so for that collision, we've got a force going this direction and another force going down. And we see that the left force and the right force, on average, those are going to end up canceling each other out. They individually might be a little bigger or a little smaller than each other, but just with the sheer number of random collisions happening, we can assume that they cancel out pretty consistently. So then our only force that doesn't get canceled out are these components of the force that act outward from the container, or that act perpendicular to the walls of that container. Now that would happen on the inside too if we have an object. Let's make that a little straighter. If we have an object that's inside, we're going to still have some molecules colliding with that, and we have some of them that hit like this and some of them that are going to hit like this, and so overall it's going to feel a force this way on this side. And then over here we might have some like this, and we might have another one like this. Overall it's feeling a force like that. And so the force from all these particles colliding with this is going to be directed inward. It's always perpendicular to the surface, and it's away from the fluid that's causing that pressure.